Namaste students, entering into permutation and combination. What is permutation? Permutation means arrangement of objects along a line or in circular way. That means there are two types of permutation, linear permutation and circular permutation. What is combination? Combination means selection only. Their order not important. So think the practical situation. Consider this bowl. In this bowl, there are 4 yellow ladus. All these 4 ladus are identical. I am placing these 4 ladus in front of you. You may take 1 ladu or 2 ladus, 3 ladus, 4 ladus, or sometimes you are not taking any of the ladus. That means if I am placing 4 identical ladus in front of you, total weight is equal to 4 plus 1. Think another practical situation. Instead of these 4 identical ladus, I am putting a orange ladu, green ladu and pink ladu in this bowl. That means here all the 4 ladus are distinct. In this case, what is the answer? You may take this green ladu or may not take the ladu. That means this ladu having 2 possibilities. This orange ladu also having 2 possibilities. Pink ladu, 2 possibilities. Yellow ladu, 2 possibilities. In that case, the answer is 2 into 2 into etc. 4 times 2 raised to 4. 2 raised to 4 equal to 16. That is the total possibility. If you take at least 1 ladu from this bowl, the answer is 2 raised to 4 minus 1. So here all the 4 ladus are distinct. That means according to combination property, out of 4 distinct ladus, you may not take any of the ladu, that is 4C0. Or you may take 1 ladu, that is 4C1. Or you may take 2 ladus, that is 4C2. Next one, 4C3, 4C4. That is the answer. What is 4C0? 4C0 equal to 1. 4C1, the answer is 4 plus 4C2. 4C2 equal to 4 into 3 divided by 2 into 1 plus 4C3. 4 into 3 into 2 divided by 3 into 2 into 1. Next one, 4C4 is 1. So the answer becomes 1 plus 4 plus 6 plus 4 plus 1. That is 16. So that is the case of distinct ladus. So in the first case, I put 4 ladus, total possibility equal to 4 plus 1. Here 4 ladus are distinct, so the answer is 2 raised to 4. So that is the difference between identical objects and distinct objects. Then entering into another practical situations. So see the practical situation. Here I am putting 6 yellow ladus in this bowl. 6 yellow ladus in this bowl and 6 green ladus in this bowl. Green ladus. Then 6 orange ladus in this bowl. 6 orange ladus and 6 pink ladus. So this is the case. So there are 6 green ladus. Green ladus 6, yellow ladus 6, pink ladus 6, orange ladus 6. That means in this bowl there are 24 ladus. Out of 24 ladus, you are taking 4 ladus. In that case, what is the answer? Consider the third case. Here, in this bowl, there are 6 green ladus, 6 yellow ladus, 6 pink ladus, 6 orange ladus. Total 24 ladus in this bowl. Out of 24 ladus, you are taking 4 ladus and permuting. Total number of permutations. That is the question. See the cases. First case, all the 4 ladus are distinct. That is why I use the notation addition in multiplication, subtraction and circle. That means out of 24 ladus, you are taking 4 ladus. All the 4 ladus are distinct. How many distinct ladus? 4 distinct ladus. Out of 4 distinct ladus, you are taking 4. So number of selection equal to 4C4. After which, permute. If there are 4 letters in your name, distinct letters in your name, how many ways of arrangement? That is 4 factorial. So first case is 4C1, that is selection, permutation, 4C1 into 4 factorial. Next case. Here, out of 4, second case, out of 4 ladus, 2 ladus identical. That means you are taking 2 green ladus. Out of 6 green ladus, 2 ladus you are taking only one way, because all the 6 ladus are identical. 6 green ladus are identical. So out of 6 green ladus, you are taking 2 green ladus only one way. The remaining 2 ladus distinct. There are 3 distinct ladus. Out of 3 distinct ladus, you are taking 2. So the answer is there is 3C2. So if you are taking 2 green ladus, the selection is 1 into 3C2. Then permuting. In your name, there are 4 letters. Out of 4 letters, 2 letters identical. The number of permutation is 4 factorial by 2 factorial. So this is 1 into 3C2 into 4 factorial by 2 factorial. Similar case also for 2 yellow ladus, 2 pink ladus, 2 orange ladus. That means 1 into 3C2 into 4 factorial by 2 factorial, 1 into 3C2 into 4 factorial by 2 factorial, 1 into 3C2 into 4 factorial by 2 factorial. So that is the case of second. What is the third case? Third case means you are creating a group containing 2 items. Only 2 items. How many groups you can create? 4 groups. In which way? That means there are 2 pink colors. That is one group containing 2 ladus. 2 orange ladus. 2 green ladus. In that way. Okay. So that is the case of third one. 1, 2, 3, 4 groups. Each group containing 2 identical items. Out of 4 groups, you are selecting 2 groups. In how many ways you can select 2 groups? 4C2 ways. Then you are permuting all those ladus along a line. So that is the case. So here there are 4 groups containing 2 numbers, selecting any 2 groups. So the selection is 4C2. Then permuted. The answer is 4C2 into 4 factorial divided by 2 factorial into 2 factorial. In your name, there are 4 letters. Out of 4 letters, 2 letters identical of one kind, 2 letters identical of another kind. Number of permutation is 4 factorial by 2 factorial into 2 factorial. Fourth case, you are out of 6 green ladus, you are selecting 3 green ladus. Remaining ladu distinct. This is the case. So that means in that case 1 into. So there are 3 distinct ladus. Selecting 1 ladu. That is 3C1 way. Then permuting. 1 into 3C1 into 4 factorial divided by 3 factorial. Similarly, in the case of pink color, 1 into 3C1 into 4 factorial divided by 3 factorial. In the case of yellow color, 1 into 3C1 into 4 factorial divided by 3 factorial. Orange, 1 into 3C1 into 4 factorial divided by 3 factorial. Fourth case, you are creating a group of 4 containing 4 green, 4 yellows, 4 pink, 4 orange colors. How many groups? 4 groups. Selecting one group, that is 4C1. Then permuting only one way because all the ladus are identical there. So in the fourth case, the answer is 4C1, that is selection, then permuting. 4C1 into 1. So in this way, out of from 24 ladus, you are taking 4 ladus, total number of selection and permutation. Based on this practical situation, I am discussing the JEE Main 2026 January question. Okay, see that question. This is the question. The word PQR triple S double T U double V. Out of this word, you are selecting 4 letters and permuting total number of words. How many total number of words you can form? That is the question. So see the practical situation. PQR triple S double T U double V. That means there are how many cases here? Case 1. Case 1 means you are selecting 4 letters, all the 4 letters distinct. That means plus into a subtraction circle. How many distinct letters in this word? 1, 2, 3, 4, 5, 6, 7. There are 7 distinct letters. Out of 7 distinct letters, you are selecting 4 letters in how many ways? 7C4 ways. After selecting, you are permuting the letters. Okay, what is the answer? 7C4 into 4 factorial. So 7C4 is the selection, permuted. 7C4 into 4 factorial. What is 7C4? 7C4 is 7C3. 7C3 is 7 into 6 into 5 by 3 into 2 into 1. That is 35. 35 into 4 factorial. 35 into 24. 35 into 24 is 35 into 20 plus 4. That means 700 plus 140. 700 plus 140 is 840. So this is the case, first case 840, which you can form. Case 2. Case 2, that means 2 letters identical of same kind, remaining 2 letters distinct. That means you are taking 2S. Out of 3S, 2S you are selecting, only one way. Okay, remaining how many distinct letters? There are 6 distinct letters. Out of 6 distinct letters, you are selecting 2 letters. So here the selection is 1 into 6C2. Then permuting. 1 into 6C2 into 4 factorial by 2 factorial. That is permutation. So 6C2 is 15. 4 factorial by 2 factorial is 12. 15 into 12, the answer is 180. Similarly, there are 2 T's, remaining 2 letters distinct. In that case, the selection is 1 into 6C2. That is selection. What is permutation? 1 into 6C2 into 4 factorial divided by 2 factorial. That is also 180. Next case, there are 2 V's in this word. Remaining 2 letters distinct. What is selection? 1 into 6C2. Permuting. 1 into 6C2 into 4 factorial by 2 factorial. That is also 180. That is case 2. What is case 3? Case 3. Case 3 means we are creating group of how many groups? 1, 2, 3, 4 groups containing 2 identical items. That means there are 2S, 2T, 2V. Okay, 2V, 2S, 2T, 2V. So containing 2 identical items. So how many groups? 3 groups. Out of 3 groups, you are selecting 2 groups in how many ways? 3C2 ways. Then permuting. So selection is 3C2. Permuting. 3C2 into 4 factorial divided by 2 factorial into 2 factorial. What is 3C2? 6. 3C2 is 3 into 2 by, 3C2 is 3C1, 3 into 4 factorial by 2 factorial into 2 factorial. 24 by 4, 6. 3 into 6, 18. 18 ways you can, that is the permutation. Next, case 4. What is case 4? There are 3 yes here. Remaining letter distinct. So that means there are 3 yes. Remaining letter distinct. That means selection is 1 into how many distinct letters? 6 distinct letters. Select 1. Then permuting. Permutation is 1 into 6C1 into 4 factorial divided by 3 factorial. In your name there are 4 letters. Out of 4 letters, 3 letters are identical. So what is this answer? 6C1 is 6. 6 divided by 4 factorial by 3 factorial 4. 6 into 4. The answer is 24. Therefore, total number of words you can form from this word is 840 plus 540 plus 18 plus 24. So the required answer is 840 plus 540 plus 18 plus 24. That becomes 2. Here also 2. 1422. Total 1222 words can be formed from this word by taking 4 letters. So see the practical situations. So these types of questions are coming in our IIT entrance. Entering into another discussion related to permutation and combination. Here I am discussing division into groups and distribution. Division into groups and distribution, I am giving a practical situation. Consider your family containing 6 members. I am dividing your family into 3 groups. At first, unequal group, then equal groups. Okay, I am dividing, there are 6 members in your family. All are distinct. Dividing into 3 groups containing 1, 2, 3. That means one group containing only 1 person, second group containing 2 persons, third group containing 3 persons. How many ways I can divide? 6 persons I am dividing into 1, 2, 3 in this way. In how many ways? 6 factorial divided by 1 factorial into 2 factorial into 3 factorial. That is the answer. In that way, I divided your family into 3 groups. Okay, that is unequal distribution. This is a case of unequal distribution. After dividing, I am sending all these 3 groups into 3 different locations. Consider the locations as A, B and C. So in that case, what is the answer there? So I divided your family into 3 groups and distributing into 3 different locations. In that case, the answer is 6 factorial divided by 1 factorial into 2 factorial into 3 factorial into 3 factorial. That is the answer. Then I am dividing your family into equal groups containing 2 persons. That means 6 I am dividing into 2 plus 2 plus 2. So that in that case, what is the answer there? Number of groups equal to 6 factorial divided by 2 factorial into 2 factorial into 2 factorial into how many equal groups here? 3 groups. So multiplying by 3 factorial in the denominator. In that way, I divided your family into groups, 3 groups of equal strength. Sending these 3 groups into 3 locations in how many ways? The answer is 6 factorial divided by 2 factorial into 2 factorial into 2 factorial into 3 factorial into 3 factorial. That is the answer. So that is the case of division into groups. Or think the practical situation. Consider the pack of cards. 52 playing cards. 52 playing cards I am dividing unequally. I am dividing unequally into 10, 10, 17, 25. 10 plus 7, 27, 27 plus 25, 52. Okay. In that case, what is the answer? 52 factorial divided by 52 factorial divided, 52 factorial divided by 10 factorial into 17 factorial into 25 factorial. In that way, I divided the 52 cards into 3 groups. Here the groups strength is unequal, 10, 17, 25. Okay, I am distributing this group into among 3 patients. In that case, what is the answer? 52 factorial divided by 10 factorial into 17 factorial into 25 factorial into 3 factorial. That is the answer. Next case, I am dividing these 52 cards into 4 equal groups. That means each group containing 13 cards. In that case, what is the answer? The answer is 52 factorial divided by 13 factorial into 13 factorial into 13 factorial into 13 factorial. How many equal groups? 4 equal groups into 4 factorial. That is division into groups of these 52 cards. I am divided into 4 groups. Then distributing among 4 patients. What is the answer there? The answer is, if I am distributing among 4 patients, the answer is 52 factorial divided by 13 factorial into 13 factorial into 13 factorial into 13 factorial into 4 factorial into 4 factorial on numerator. That means, in that case, the answer is 52 factorial divided by 13 factorial raised to 4. 4 factorial get cancelled. So this is the answer to that question. Okay. So in this way, division into groups, theory parts are the practical situations. So division into groups is very, very important. I think you got the idea about permutation, combination and the division into groups. These theory and the practical parts are very important. Thank you.